Good afternoon. Welcome to our panel on shaping technologies. I'm David Mindell, professor at MIT and co-chair with David Autor and Liz Reynolds on the Work of the Future task force. One of the key messages of the report that came out yesterday is that technology is not something that happens to us. It's something that we shape and create. And President Reif's remarks this morning, opening up this Congress, emphasizes that AI embeds the values of its designers into the technology. So as MIT, as a place that both invents technology and creates inventors, the question for the next 45 minutes is how do we roll up our sleeves and get this done? How do we shape the educational mission, the technological mission, and the innovation? I'm joined today by Professor Daron Acemoglu, Institute Professor at MIT, which is the highest academic rank and also a member of the Department of Economics. Daniela Rus, Professor of Computer Science, and as you heard this morning, Director of the Computer Science and Artificial Intelligence Laboratory at MIT and one of our co-hosts of this conference. Julie Shah, Professor of Robotics and Specialist in Collaborative Robotics, and also a member of the task force, as is Daniela. And I should also say Julie's book just came out about maybe 2 days ago, What to Expect When You're Expecting Robots, an excellent exploration of what robotics looks like on the ground in the real world and what's coming. And Jeanne Magoulick, an engineering supervisor at Ford Motor Company and deeply involved with Ford's thinking about the factory of the future. So the overall overriding questions for us here are, how do we shape technology to support and augment workers more than replacing them? And what do we see coming down the pipe that could help us do so? But maybe I'll start with a few more targeted questions for the panelists. So Daniela, you're both an AI researcher in your own right. You lead your own laboratory, and you lead one of the great larger laboratories in AI around the world. What are ways that research leaders can shape technologies in these ways toward larger social goals and influence the kinds of inventions that our students and others are making?
Thank you, David, for this question. So let me start by saying that in the area of artificial intelligence, machine learning, and robotics, which are the technologies that are advancing our ability to have these more powerful tools for people, all of this work is by the people and for the people in some sense. Within a research laboratory, we aim to develop the science and engineering of intelligence and the science and engineering of autonomy. This means we're identifying increasingly more complex, increasingly more well-developed ideas about what machines can do for us. Now, in the process of developing these new capabilities, it is also very important to be responsible, to think about what these machines will be used for in the future. We can't stop technology from advancing and from changing the world, but we can stop, we can pause to ask, what are the consequences, and make sure that we are held accountable for these consequences. And so increasingly, we're talking about responsible disruption, meaning the idea that researchers and companies ought to be accountable and more responsible about the technologies that they create. Now, on the technical side, we're talking a lot about artificial intelligence or intelligence demonstrated by machines, but it's important to distinguish between the kind of specialized intelligence that we can give our machines today and general intelligence. And I'd like to underscore that today's AI, what we can do with AI systems is essentially specialized intelligence, or the ability to solve a very fixed, very limited number of specific kinds of problems. And this is in contrast with general intelligence, which humans possess, which give us the ability to undertake a wide variety of different tasks in a broad range of settings. We have machines that can do some things better than people. We have people who can do some things better than machines, working together we can be more empowered. And if you'll give me just 30 seconds, I will give you an example from medicine where doctors and AI systems were given the task to classify scans of lymph node cells and declare them cancer or not cancer. The machine made 7.5% error as compared to the human's error at 3.5%. But when they worked together, the humans and machines achieved 80% improvement or 0.5% error, which is extraordinary. This kind of example is applicable across many disciplines. So let us look at the tools that come out of the AI, machine learning, and robotic community as tools to help people, to empower people, to support people with cognitive and physical tasks.
Thank you. That's a terrific example. Daron, your ideas have been very influential on the task force's work, from everything from taxation policy to this notion of socio-technology. And I wonder if you might explain your idea of what socio-automation is, and if you have ideas about how we might find our way out of it, with, of course, the acknowledgement and the recognition that you're on a panel here with 4 engineers and you're the lone economist.
Okay, I'll try to represent my discipline. Although I think the problems that are afflicting us are made by all of us, not just by engineers or economists. I think it's this joint mess is ours. So, you know, what I mean by socio-technology is that it's technology that doesn't really bring transformative productivity improvements. And that is a real problem when we are talking of automation technologies, because you know, the hope has always been that even though we are automating tasks and taking jobs away from people, we will be creating almost automatically jobs in other parts of the same organizations or other parts of the economy. But that doesn't happen unless you have a very large productivity benefit. Socio-technologies are those that are really not creating that productivity benefit. Think of self-checkout kiosks. You know, you may be a fan of them or you may hate them, but we are not going to transform the US economy using more and more self-checkout kiosks. At best, the productivity improvements from them is small. At worst, we're actually adopting them because of other reasons such as tax policy. And the solution to these issues is actually relates very much to your first question, David. It's not that we can transform socio-technologies into much better technologies by putting more effort in them. It is that we need to have a more balanced portfolio of technologies. We need more technologies, more ways of restructuring the economy so that we put humans first. And that, whatever anybody says, I believe we're not doing. We are very much beholden to an automation alone mentality. And we are just going after exactly the same things that have taken us a little astray over the last 3 decades. Algorithms for getting rid of humans, algorithms for doing things that humans could do, algorithms for things that we think troublesome humans could be put aside. And if that's our growth model, it's going to run into problems in terms of productivity growth, but worse, it's going to create a dystopic society.
So Julie, you're actually a leader in the things that both Daniela and Daron have just talked about: human first technology, human first AI, and collaborative robotics. And a major part of the task force work was your work going to Europe and looking at the deployment of some of these technologies in Germany in particular at both robotics companies and manufacturing. And I wonder if you could say a little bit about what you've learned. It's embodied in one of the task force research briefs, and what the implications are there for how we might innovate for the work of the future.
Yes, so my research team, in collaboration with others on the task force, went and interviewed a number of manufacturers, suppliers, and firms, small to large, in Germany and throughout Europe. And to look at, 7, 8+ years into this mega trend of Industry 4.0, look at the technologies that were being deployed, what were the enablers, what were the hurdles, and what can we learn from that. And I'll highlight kind of 2 key takeaways from this study. For me, that's particularly, I think, important to thinking about how we shape technology as an AI researcher and as a roboticist. One is that it's not about the particular technology, say the robot or the collaborative robot that you develop on its own. We saw different perspectives and different approaches for deploying and integrating those systems into the industrial environment. So what we called sort of top-down versus bottom-up approaches or mindsets. In a top-down approach, the system is developed and programmed sort of separate from the line and the workers with the domain expertise for doing that job, and then deployed to do the work. And in contrast, other approaches where the system was programmed and developed with the engineers working side by side with the domain experts, the folks that do the work manually today, and with different results from those. And those two approaches span both the small firms and the large firms. But the ones that were able to leverage or incorporate the domain expertise for doing the job had better results. The technology we have today doesn't easily support that. It usually requires special expertise to program these systems. It's very time intensive, resource intensive, and then that leads to other challenges. So as the work evolves over time, one of the questions we would ask is, well, where do you see the introduction of these technologies going? Thinking about moving towards a lights out factory. I think one of the quotes we got back is especially illustrative. One of our interviewees said, a lights out factory, why would we want that? A lights out factory is a factory that's not innovating and improving. And that's because it's humans that drive the innovation process. But the technologies that we deploy today sort of lock in the sort of state of knowledge, the way we do the task, and it makes it very hard to leverage that human innovation and that human domain expertise to improve. And that improvement is what every factory relies on, a well-characterized sort of productivity or learning curve through, say, the assembly process. We see a similar trend in healthcare. So in my work in developing intelligent decision support for nurses and doctors that, say, run a labor and delivery floor in Boston Hospital, when you deploy automated planning and scheduling techniques, when they don't incorporate the sort of on-the-ground implicit knowledge and preferences, they're disused. And people find workarounds to them. And so in our lab, it requires sort of reframing the AI problem to be able to learn from, to actively learn and update the models that are used to either augment human decision-making for these scheduling processes or to offload or support in other ways. And all of this speaks to how we need to redefine the AI problem as an enabler towards more widespread use of these technologies to our benefit.
Wonderful. That segues us nice into question for Jeanne. You have the privilege of working for the Ford Motor Company, which invented the revolution in mass production more than 100 years ago. In fact, every day I drive by the Model T assembly plant at the end of our street here in Cambridge. Most people don't realize there is one here, but it's a wonderful little building. And now you're in the enviable and very important position of helping Ford conceive the factory of tomorrow. And I wonder if you could talk a little bit about how you see the relative role of machinery, automation, robotics with human workers, human intelligence, human augmentation in that Factory of Tomorrow initiative.
Yeah, thank you. You're right. We have Ford Motor Company has a long history of innovation, and the Factory of Tomorrow initiative is really a continued step in that direction for innovation. The Factory of Tomorrow initiative is really trying to reimagine manufacturing to build smart vehicles for a smart world. And through our research, we know that we have to keep innovating to be a manufacturer of the future. And as part of our Factory of Tomorrow initiative, we developed strategies for creating smart factories using technology. We're also cognizant of creating a strategy for a digital factory. Digital engineering is another big aspect. And then the analytics. So once we have all this data, how can we use smart analytics so that we can use the data in an elegant way, if you will. And then we're also using, we have a group called Process Innovation that works very closely on our on advanced robotics. And in particular, they do a lot of experimentation, proof of concepting and pilots on cobots. as well. And we're starting to do a lot of experimentation on using AI in our automation systems and also vision systems. We've been using AI for several years in vision systems as well. Additive manufacturing is the final area where we're still maturing that capability, and we see a lot of growth in that area as well. I will say that our vision really is to become the world's most trusted automotive company for all of our stakeholders, and that includes our customers, the distribution network, supplier partners, and then most importantly our employees. And people are really integral part of our Factory Tomorrow initiative. Last year, Ford completed a $35 million renovation of the Ford UAW Technical Training Center. And that update included a revamped curriculum to include training our skilled trades workers on advanced manufacturing technologies. And we're also working in lockstep on the technologies we're developing in the advanced manufacturing area with our learning and development partners as well. We've developed the first of its kind for Ford, a technology and people workshop. So for new model programs where we're deploying technologies, we're identifying the skills, the knowledge, the training, and even organizational changes that might be required for successful adoption of these new technologies.
Yeah, these days when I visit an automotive plant, I often see it as a giant collaborative robot itself that employs hundreds of robots and thousands of people and other kinds of infrastructure all working together. Daron, what do you think is the best way to ensure that we're developing technologies that meet social needs? And I know you have some ideas for policy steps that could nudge us in these directions.
Thank you, David. I think that is critical. And you're right. I have written about policy steps such as tax policy that can nudge us in that direction. In particular, emphasizing that right now our tax code subsidizes firms to automate because we tax capital much more lightly than we tax labor. But actually, we need to step back. Nudges are one thing, but we actually need a more holistic approach. We need to agree as society, that means businesses, consumers, about the consequences of technology in the same way that there is now a broad agreement on the consequences of pumping carbon into the atmosphere. And a lot of consumers are worried about that. A lot of businesses are worried about that, especially in Europe. US is behind, but it is a general social norm that has developed on this topic. And government policy evolves around it. And when you look at, again, climate change or nuclear energy, there is a variety of voices on that matter. No company can adopt nuclear energy without checking a lot of safety items, and there will have to be various voices that you have to hear. But when the same is in the area of technologies that are going to shape the future of the workforce, whether people will have jobs, what type of people are going to benefit from economic growth, none of that is the case. I think most AI researchers have almost no recognition of the social consequences of what they do. That's why, thousands of people with impunity would work for companies that are preparing technologies that are just for snooping over individuals and are suppressing human freedom. But it doesn't just end with monitoring technologies. I think there are social consequences when you put all of your effort in automating work rather than helping humans or creating new tasks for humans. If you look at around you, most of the people you know today are performing tasks that did not exist 80 years ago. Even professors, we exist as an occupation, but if you look at what professors did 80 years ago, that's very, very different from what we do today. All of these things emerge because we used technology to create new capabilities for a lot of workers. But that has largely ceased or has become much less important over the last few decades. So we need to recognize that, and we need to develop a holistic approach to it. And that starts at the bottom with society, it starts at the top with the government, and companies are, of course, critical. But most critical, perhaps, are the researchers. And I think the researchers need to wake up.
So speaking of which, a last question, the same for our three engineers on the panel. Daniela mentioned collaborative AI for radiological evaluation, and we've talked about collaborative robotics. What else do you see coming down the pipe that's exciting to you that has potential positive implications for human collaborations and workers and work and addressing some of the issues we've seen? Maybe Daniela.
David, I would like to jump in and talk about transportation in general, or more broadly talk about the notion of a machine as a kind of a guardian for the person. This is a concept that MIT and the Toyota Research Institute started working on together about 5 years ago. The idea is that you're not going to have self-driving cars, level 5 autonomy for a while. But what you can have is a parallel autonomy system that can use extensive sensors to look at the road and prevent the human from making a mistake when that mistake is about to happen. In the same spirit, we can have systems that can monitor a surgical procedure and give the surgeon early warning that a blood vessel might be about to explode, and this could be the difference between life and death. We can imagine applying this notion of a guardian system to many aspects of many technological aspects. And including manufacturing, we can give early warnings that a piece of equipment might be about to get damaged, and that could save a lot of money. There are many ways in which we can help support. And some of these ways, in fact, are also new ways. Daron was talking about how people do different tasks that we didn't used to do some time ago. And I would just like us to think a little bit about how many people are employed in social media roles with a varied level of skill and talent. And so these jobs didn't exist before social media existed, and social media didn't exist until about 15 years ago. So it's sort of exciting that we see activity, we see innovation, but at the same time, we have to be very careful about how we proceed.
Thanks, Julie.
Yeah, so I think we're at a quite exciting time, with the examples Daniela has mentioned and many others where. Maybe previously when we think about how to decompose the work between a human and an intelligent machine or a robot, sort of done by task, what tasks will the machine do, what tasks will the person do? But if we think differently about what the relative strengths of humans and machines are, I say our human ability that we really want to be able to leverage maximally is our human abilities to structure an unstructured problem. And then once we have a structured problem, a computer or machine can kind of crush it. But the means we have, and that's a different decomposition, right? But the means we have for structuring problems for machines or for AI is still so limited today. It's collecting lots of data and painstakingly labeling it, which is not something people are sort of well suited to do. It's not how a person sort of communicates or translates knowledge to another person. Or in the case of an industrial robot, painstakingly sort of programming line by line how that work is done in a way that's quite rigid. And so, these robots, the AI, will never be infallible. And the key thing is to figure out how we can match up our capabilities and open sort of transparency and explainability with these systems so that we can, the system is a guardian for us, but in a sense, we're also a guardian for the system, and the system can leverage or benefit from our very unique human ability to structure unstructured problems. That's valuable for physical work, like in factory settings, but also for supporting cognitive tasks in healthcare, many other domains.
Yeah, as we think about guardians, which I think is a great idea, and the parallel autonomy that Daniela mentioned is really valuable. The 737 MAX is in the news today again for being returned to flight, and you could interpret that problem as a Guardian problem where the Guardian and the pilots were fighting with each other with awful results. There are other issues there too, but Jeanne, what excites you coming down the pipe from the Ford point of view and from a manufacturing point of view as far as new technology in collaboration?
Well, I think adding on to what Daniela said about predictive maintenance, this is something that we're really excited about. And really, it is going to make us more efficient. We're going to be able to schedule, notify when a machine seems to be trending out of control and may need some maintenance. And then we can schedule that at the next available window, for efficiency. So we don't have to wait for the machine to go down, or even it's like the next level of preventative maintenance, which is what we do today, which is not is predictive is obviously much more better, much more efficient, and it'll also help us with order replacement of parts. So we could potentially, if we know that a part is going bad, rather than having that part in our inventory and sort of holding our free cash flow in our inventory, we can free up that cash flow and order it on demand, as an example. Other areas, as I mentioned, we're really advanced and mature in using AI and vision systems, particularly for quality defects. An example would be like a paint chip and scratch. It used to take us thousands of images to train a vision system to look for a defect, and now it's very few, and it can look for that defect anywhere on the vehicle, which is really made us more efficient. Second, we're as I mentioned, also we're using automation, AI in our automation to really use machine learning to see if we can reduce our cycle time and improve our FTT as well in certain applications. We just recently reviewed a use case for a transmission assembly part. And it did, the data did show that it reduced the cycle time and slightly improved first time through as well. We're also developing natural language for manufacturing to use voice commands to communicate with machines. And think of it as kind of like Siri for manufacturing, which is really exciting for us. And finally, we're looking at deploying AI to help us evaluate quality defects that make a noise, like two connectors going together. So there's an acoustic or vibration signature that goes along with that, making that connection and that noise, and using AI to kind of learn what's a good signature and what's a bad signature. So those, and then obviously, collaborative robots and collaborative remote team tools we're using for training on some of our new model launches as well.
Wonderful. We're getting a lot of good questions from the audience, so clearly people are really engaged in this conversation. And I'll start with one for Julie. You mentioned that it's important to get the domain experts involved early in the process, and the question is, who are those domain experts? Can you go into a little more detail about where that knowledge comes from?
Yeah, I think there's multiple sources of the knowledge that are required to develop and deploy the system, but in particular, the domain expertise of the person on the shop floor that's actually doing the job today. And so many of these jobs I've learned through our own work in the lab. Many of these jobs are learned through kind of like years of apprenticeship in some cases. Jobs that you think might even be relatively easy for a person and could easily be translatable to a robot can be more challenging than at first look. And so, for example, placing stock to prepare it for sort of heating, sort of parts that are all sort of different sizes, but they need to be placed in such a way to go into the oven so the air flowing through it heats them all uniformly. And you'd say, well, wouldn't it be great for a robot to pick and place the stock just into the bin and put it into the oven? But it's actually a trained skill to be able to kind of get that right, that humans are quite good at, and that can be challenging to program in some settings. And so, first through being able to learn from observation, learn from demonstration, but even be able to directly elicit from someone doing the task on the floor, the key factors that go into doing this job successfully. And then people doing the work today also are the right ones to help envision the different ways the task can be done with the use of a new technology, sort of that more open space of sort of alternate ways it can be done. That a robotics engineer or an AI PhD is not going to be well suited to do on their own.
Great. Question for Daron. What do you think will help researchers become more aware of the social consequences of their work? Top 3 strategies.
I think I was just going to give 3, so good that you asked for 3. I think the first one is training. I think much more ethical and social training is necessary. I don't mean abstract ethics courses. I think those have been tried in MBAs and haven't always been extremely useful, but much more concrete understanding of what the social implications of different technologies are. Second, government policy. I think government is the trendsetter. Laws are signals. Government priorities are signals. If the government itself sort of gives up on the agenda of creating better technologies for humans, it's natural for researchers to do so. But the third one is most important also, and that is autonomy and independence from the corporate world. According to some estimates, the McKinsey report says $2 out of $3 that goes into AI comes from the big tech in the US and a handful of Chinese big tech companies. Those companies are the ones that also fund most AI labs, and they have their own agenda, unsurprisingly. And their agenda often is not the one that we're talking about. Most of these companies are very lean. They are built on automating work, substituting algorithms for humans, and don't really have an organic relationship to manufacturing or new technologies that are going to create new tasks in different sectors of the economy. But if those companies set the tune in leading AI labs, and moreover, most students are getting into AI and computer science to go and study in these companies, how can we expect the AI research that comes out of that process to do anything but replicate and parrot those companies' priorities? But if you look at all leading US universities, it's the opposite right now, including MIT. So this is a very, very difficult lesson, but I think it is one that we'll have to come to grips with.
When you say the opposite, what do you mean by that?
Meaning that we are doing the opposite of that. We're not really establishing our autonomy. We're actually saying that good research means we have to be more integrated with Google, Facebook, Microsoft, Amazon. But of course, we have to work with many companies, but autonomy for research is critical, especially in this area.
Daniela, do you have thoughts about that, about the autonomy of research vis-a-vis funding sources in AI today?
Well, I think that there is a fair bit of autonomy, and there are a number of programs that support independent, curiosity-driven research. Problem is that we don't have enough funding of that form. So I mean, in some sense, where the government is lacking, the companies are stepping in. But working with companies, I find can be also very enriching and empowering. So I will give you some examples. I'm going to come back to our collaboration with the Toyota Research Institute, which started 5 years ago, and the objective of that program was to advance AI, advance the science of intelligence, advance AI and robotics research. So there are different levels at which we can connect with different potential sponsors. I have to say that when I think about how universities, industry research labs, and development connect together, I have this mental model where an industry development lab works on products for today. An industry research lab works on products for tomorrow. But the role of the university is to imagine the day after tomorrow. And the day after tomorrow involves advancements, foundational advancements, but also connections with how those advancements matter. And in the absence of applications, we can generate a lot of theory, but applications also allow us to root our ideas into things that the world cares about.
So as a final question, there's a question from the audience about, as we've talked about unique human capabilities, social relationships, and even physical manipulation to some degree, what are the potentials for AI? And the questioner particularly asks about GANs, generative adversarial networks, which is a more experimental kind of AI that's been been used in various kinds of artistic creation. How much do we worry about what we consider today's unique human capabilities being overtaken by the next generation of AI?
I can say something on that. I think it is a choice. There isn't an ironclad rule of what it is that humans can do and technologies cannot do. They are all both fluid. It depends on what we value and how we use technology. And much of it is hard to imagine. So when we were going through the previous examples of major automation waves, for example, mechanization of agriculture, contemporary thoughtful commentators couldn't see what new tasks and new human capabilities would emerge. Those were things that changed as technology was deployed in various different ways. The factory floor was completely transformed in that process, for example, where today most factories employ more non-production workers than production workers. That is a major change in technology and uses human capabilities in a completely new way. So entertainment, we can use technologies to make human elements in entertainment completely unique, or we can change technologies in such a way that human element in entertainment industry becomes less and less. Again, it's a choice of how we train the humans, how we train and develop the technologies, and what as a society we come to value and understand. So that is why I think the most important lesson that the report makes is that technology is not something that has a definite path. There isn't a path of technology that technology itself or its leaders want that's the right one, but it is something that society as a whole has to forge.
Julie or Jeanne on that topic?
Yes, so I agree with Daron's comments there. I think that there's maybe there's a sense that we develop these technologies and they're going to overtake human capability, but they are still performing very narrowly defined tasks that we define, and we determine how they're embedded and how they're used. So. Like for example, deep learning neural nets, they're like very fancy function approximators, right? They're like a way to model things, like as is algebra, as is calculus, but it's how we then take those tools and use them for a purpose in real systems where there are a lot of questions of what is our end goal? How do we define success for introducing these systems? Are we aiming to enhance some human capability? Is there a goal to replace some aspect of what a human is doing today? But none of these systems ever operate truly independently. There are inputs to them, and there are outputs, and there are human decisions based on the output of these systems, and so taking that more holistic view and asking, what is the way that we can deploy these technologies to achieve our larger goals is really the critical question we need to be grappling with.
So if I can add to the conversation, I would say that an important part of what we do at MIT and in the scientific community is to advance the science and engineering of intelligence. And in doing so, we accomplish many things. We understand ourselves, we get a better handle on life, and we develop capabilities. We develop machine capabilities that have an increasingly broader range. Now, in the process of developing these capabilities, we get to the point where the kind of ideas that we develop with long time horizons can be put into action today. And I, for one, am very excited about the possibilities of using the latest advancements in AI, machine learning, and robotics to bring more powerful tools for people, to make certain jobs easier, to make life easier. Look, we wouldn't be here together if not for technology. Technology is enabling us to come together despite the fact that the world is in the middle of an epidemic. Technology has also accelerated the rate at which we have achieved an effective vaccine. Technology is enabling scientific discovery in so many fields. Technology is helping us better engineer, monitor, and treat disease. Technology is keeping us safer on roadways. Technology is enabling us to communicate instantaneously, no matter what language we speak. There are so many ways in which machines can take on some of the routine tasks that we do so that we can focus on broader, bigger, more creative ideas.
Wonderful. I think we're out of time. I want to thank all of our panelists and for a very interesting conversation. And also, all of our panelists are part of major contributions to the task force work and report itself. Ford Motor Company has been very supportive and open about some of their processes they're going through. Daniela and Julie are actual members of the task force. Daron is not formally, but has been very supportive and wrote one of our briefs and had major impact intellectually on our work as well. So thanks to all of you, and thank you for your important voices on this topic and finding its way into the report and into additional research and innovation. So with that, we'll wrap it up and go on to the next panel.
Thank you, David. Thank you, everybody.